Hey everyone, we use the internet pretty much every second of every day, right? It just feels like magic. But it's not. Behind every click is this incredible high speed journey. And in this explainer, we're going to pull back the curtain and see what's really going on.
I mean, really think about it for a second. You type a website into your browser, you hit enter, and boom, it's right there on your screen. But that split second is hiding a seriously epic adventure. So today, we're going to follow that adventure from your fingers on the keyboard all the way to a server that might be halfway across the world and all the way back.
All right, so let's dive right in. The journey starts with something you've probably done 1,000 times already today. You type google.com into your browser. What actually happens in that microsecond after you hit enter?
Well, here's the first surprise. Your request doesn't get sent out as one big file. See, sending a huge chunk of data across a network it's a terrible way to do it. It's like trying to send an entire encyclopedia through the mail in one giant box. So instead, the system shatters your request into thousands of tiny, manageable pieces.
And that brings us to the hero of our story, the packet. Now, the best way to think about a packet is, well, it's like a tiny digital postcard. Each one has a little piece of the overall message, the address it's going to, a return address, and, this is key, instructions on how to put the whole message back together when all the other little postcards arrive. So our little packets are all packed and ready to go. Their first big hurdle is just getting out the door. They've got to get out of your house and into the wider world. And here's how they pull off that great escape. It all starts at your computer's network card. From there, the packets are fired off, either flying through the air as Wi-Fi signals or zipping down a good old-fashioned Ethernet cable. And their very first stop is that little box with all the blinking lights you probably never think about, your router. You see, your router is basically the gatekeeper. It's the bridge between your private little home network, your phone, your laptop, your smart TV, and the massive public internet. It's the local post office that takes all your little digital postcards and sends them on their way to the outside world. Okay, so our packets have officially left the building, but now they have a problem. They know they're looking for a place called google.com, but here's the thing. In the digital world, a name like that doesn't really mean anything. They need a number, a specific numerical address. So where do they get this number? Well, the first stop after leaving your router is your internet service provider, your ISP, the company you pay every month for internet access. They're the on-ramp to the internet superhighway, and they hold the mat. And this really gets to the heart of it, right? We humans think in names. Google.com, it's easy to remember. But computers, the machines that actually run the internet, they think in numbers, these long strings called IP addresses. Every single device on the internet has one. So the big question is, how do you translate the name into the right number? That is the magic of something called the DNS, or the Domain Name System. And it's pretty much exactly what it sounds like. It is the internet's phone book, a massive, globally distributed phone book. When your ISP gets your packet, it does a super fast DNS lookup to find the correct IP address for google.com. All right, our packet has its address, it's stamped, it's ready, and now it's time for the main event, a ridiculously fast trip across the backbone of the entire internet. And this is a really important thing to understand. The internet isn't just one big cloud. It's actually a massive, sprawling network of networks, thousands of them, all run by different companies and organizations, all connected to each other. And our little packet is about to hop between a bunch of them at lightning speed. And get this journey is physical. Your packet could be traveling as a pulse of light inside a fiber optic cable, thinner than a human hair, buried at the bottom of the Atlantic Ocean. Or it could be beamed between microwave towers, or even bounced off a satellite orbiting the Earth. At every step of the way, these super smart routers are making split-second decisions, calculating the absolute fastest path for your packet to take at that very instant. Okay, so you've got all these different networks, all this different hardware. How does it not all just fall apart? How does it all work together? Well, the secret sauce is a set of rules called protocols. It's kind of like international shipping, right? It doesn't matter if a package travels by truck or plane or ship, they all use a standard address label. That way, the postal worker in another country knows exactly what to do with it. Protocols do the same thing for our data packets. Okay, so after an incredible trip, bouncing across oceans and continents in a fraction of a second, our little packet is finally closing in on its destination. It has arrived at a gigantic building called a data center, ready to deliver its message. Imagine a warehouse the size of a football field, just packed with humming computers. These are the servers. These powerful machines have one job: to hold on to all the stuff on the internet, like web pages, and serve it up when someone asks for it. Using that IP address, our packet finds the one specific server it's been looking for out of thousands.
And here's something amazing. All the other little packets from your original request, they're all arriving too, but they might have taken completely different routes to get here. And that's actually what makes the internet so robust. If one path is slow or blocked, the packets just find another way. The server collects them all, uses their built-in instructions to put them back in the right order, and finally understands your complete message, "Hey, can you send me the Google homepage?"
But wait, we're only halfway there. The server has what you want, but now it has to get that web page all the way back to you. So that whole epic journey is about to happen all over again, just in reverse. So the server grabs that Google homepage, shatters it into thousands of new packets, and this time it addresses them all to your computer's unique IP address. They launch back out across that global backbone, find their way to your ISP, then to your home router, and finally they land on your device, where your web browser instantly pieces them all together to display the web page on your screen. And here's the absolutely wild part. This whole thing, the round trip from your keyboard across the world and all the way back, it happens in less than 100 milliseconds. I mean, that is literally faster than the blink of an eye. Incredible. So the next time you just casually browse the web or tap on an app, remember what's really going on under the hood. It isn't magic. It's this beautiful, chaotic, and unbelievably fast dance, where every single action you take launches an army of tiny data packets on a truly epic global journey. And that really makes you wonder, right? This incredible system was designed for a certain kind of world. But now, we're connecting billions more devices, our cars, our fridges, you name it. And new technologies like AI are demanding more data than we ever thought possible. So the big question is, how does this amazing journey have to change to keep up with the world of tomorrow?